All right, here we are on page 3. And on this one, we're going to take rectangular coordinates and convert them to polar coordinates. And we just did that at the very, very beginning of this lesson, so it shouldn't be too difficult. So this is a rectangular point, -6, 0. So I'm going to go ahead and plot that. So that's -6 on my x and 0 on my y. So how would I put this in polar units? Well, there's a couple ways I could approach this, right? I could say that it is 6, and then the angle, remember this is my polar axis, and I would go all the way over this way. So my angle would be pi. I could also say that it's 6 and 180 degrees. It's another way to write it. There's also one more thing I could do. Remember when we have negative values? What I could do is, because this is on a negative x-axis, I could say it's -6 at 0 degrees, and then that would flip it 180. So probably the most common you're going to see are these two here. There's no reason to make it more complicated if you don't need to. Okay, so now let's go ahead and plot the point 0, -4. Okay, with 0, -4, I could do this angle here. Um, I have 3 other ways to represent. Okay, so here they want us to do several. So let's go with 4 to 70 degrees. Okay, and then what we can do is look at what our equivalent is if we pull this in to our unit circle, right? So 270 degrees is the same thing as 3 pi over 2. So I could say 4, 3 pi over 2. What I could also do is, instead of having this axis, I could go to this axis and make it negative. So I could go -4 pi over 2. And I could also go -4 at 90 degrees. So there's a couple ways to write it. Again, I wouldn't necessarily immediately go with a negative value. It's asking us for multiple, but there's really, again, no reason to overcomplicate it. Okay, let's see what they want here. Convert from rectangular coordinates to polar coordinates. Let's do it again. All right. I want you to go ahead and see if you can get this done. Please pause the video. We've gone through 2 examples. You should be in good shape. And then we'll come back and you can take a look. All right. Let's look at the point -3, 3. So -3 is here, and I'm going to go up 3. So that's this value right here. The point is in quadrant 2. From the pole, draw in the polar axis and the terminal side of the angle theta to find the distance from the pole to the point is called r. So I'm going to draw a line coming through that. Oops, that wasn't too good. Let me do a little bit better. Okay, so that line coming through that, and this value is going to be r, and this value is going to be theta. The relationship between r, x, and y is, well, remember when we did our Pythagorean theorem? So if we had um, x squared plus y squared equals r squared, right? We already did that up above. And so that's actually um, what we're going to be able to do to solve this. So I'm going to put this in here, x squared plus y squared equals r squared, and then let's do this. So -3 squared plus 3 squared equals r squared. So 9 plus 9 is going to equal r squared. And to get rid of that square, I'm going to have to take the square root. Okay. Now, for those of you who, I don't know how it is that people taught you how to see if you can pull any numbers out of a root, I've always done a factor tree. So if I have 18, I can divide that into 2 times 9, and then that 9 is 3 times 3. So I would probably rewrite this as 3 root 2 as my answer. Okay? The relationship between theta, x, and y is, we talked about that already also. It's the tangent of theta is equal to y over x. Use this to find theta, to get theta in the correct quadrant. Ooh, something must be added. So we're going to talk about the quadrants in a second, but let's go ahead and write out that value. So tangent of theta is equal to, we have 3 over negative 3, right? So the tangent of theta is equal to negative 1. Now, when you're in different quadrants, your tangent is based on your x-axis. So if you have something in this quadrant, sure, it's to the positive x-axis, you do nothing. Okay, this is quadrant 1. If you are in quadrant 2, it will give you the angle with respect to the negative x-axis, and it will be a negative angle, right? So I want you for a second to go ahead and take that tangent of theta and solve on your calculator, right? You're going to take the arctangent. Let's see here. So the inverse tangent of negative 1 is going to give us negative 45. Okay. So negative 45 is what this is going to be, negative 45. So what you're going to have to do is add 180 if you're in quadrant 2. Down here, it will give it to you as a plus angle. So this one would be, right, if this is 45, this would be plus 45. But notice in quadrant 3, it gives you the same number as it does in quadrant 1. So if you know it's in quadrant 3, meaning that both your x and your y are negative, again, you're going to add 180. And then if it ends up in quadrant 4, so quadrant 4, you're going to add 360 because it's going to give you a negative 45 degrees on that one. Okay, so do nothing in quadrant 1, add 180 in quadrant 2, add 180 in quadrant 3, and add 360 in quadrant 4. Now, if this is in radians, we're going to affect that in radians. So we would add pi for quadrant 2, add pi for quadrant 3, and add 2 pi for quadrant 4. Okay, so if I have 180 degrees plus negative 45, right? So that would give us 135. So 135 degrees is our angle, or we can take a look at the equivalent of what 135 is, which is 3 pi over 4. Okay, so both of those are good answers on that one.